Good morning, everyone. It's my honor here to have a talk about building Go projects with Gradle, and thank all of you for spending your time with me. First of all, let me introduce myself. My name is Zhang, and previously I worked at Alibaba, and now I'm unemployed, so maybe some of you could give me a job. This is my GitHub, where you can find the keynote of this talk and something else. So before I start, I want to know how many of you are familiar with Go or have written Go code. Please raise your hand. Okay, so many people. And how many of you have never heard of Go? Oh, good, yeah. And in case some of you are not familiar with Go, I'm going to take a brief introduction. So Go is a programming language developed by Google and first released in 2009. It's static typed and compiled language with support of concurrency and garbage collection. So have you found the fact that these four characteristics are exactly the same with Java? Yeah, Go is pretty much like Java, but there are many differences we'll talk about later. And Go is a promising language. You must have heard of Docker, which is written in Go completely. And Go is the programming language of year 2016. In addition to Docker, there are an increasing number of excellent applications in Go's ecosystem. We have Kubernetes, container orchestration system, and Gogs, a popular Git service server, and etcd, a reliable distributed key-value store. So now that Go is so similar to Java, which two are mostly used to build Go projects? The answer is make. So Go has so much in common with Java. Why can't I use it? Why can't I use Gradle to build Go projects? And why do we solve problems that have already been solved many years ago? Soon I found building Go is so similar to building Java that I can use many concepts and wheels in Gradle. Because they have already been proven reliable and mature. So then I wrote a plugin named Gogradle to provide full build support for Go language. To apply this plugin, you just need to use the plugin syntax we are all familiar with. And the Golang block here is a project import path of your project we will talk about later. So the first problem we're faced with is how to install Go distribution, right? And with Gogradle, it's pretty simple because you don't need to do anything. If you don't do anything in your build.gradle, Gogradle will download and install the latest version of Go for you. But maybe you want a specific version, so you just need to write Go version equals that version in build.gradle. Let's see a demo. I'm going to use Gogs. You have heard of Gogs? Gogs is a popular Git service server which has about 20,000 stars on GitHub. So it's written in Go, and we can use it. We can see we are on the stable version of 09113. And the only extra file is build.gradle. Let's see what's in it. I should. Can the back read this? OK, just plugins and Golang block. This is its package import path we will talk about later. So I guess the latest version is 1.8.3. So I'm going to use 1.8.2. Let's see what's going to happen. OK, I just need to run Gradle build. You can see it starts downloading 1.8.2. I'm going to kill it because it's a bit large. Let's go on. And in other words, with Gogradle, you don't need to care anything about the distributions, just focus on writing Go code. And the next part is package management. In Go, generally speaking, all stuff is located in a global and single workspace named Go path. And all Go source code locates in the directory src. So Go source code is grouped into packages, and its file system hierarchy indicates its package path. In this illustration, demo.go has the package path github.com/my/demo. It imports github.com/another/package. So the directory src github.com another package will be searched for this package. And what's more, a Go path is an environment variable. It is a string which can contain multiple paths separated by colon or semicolon, depending on the operation system. Does this look familiar? Yeah, in Java, many years ago, we put our jars in a global environment variable class path. And when a package is imported, we find the package in those jars. What's the disadvantage of this mechanism? Obviously, it lacks version information. I can see I want to use version 1 of the package in this build and version 2 of the package in that build, right? Yeah, so how do we solve this problem in Java? Maven's solution is artifact. We are all familiar with the project level class path will pass via -cp parameter. And in Go 1.5 introduced a mechanism named vendor after communities complaints, you know. And that mechanism is putting a directory named vendor in project root, and the code in vendor has higher priority than the code in the global Go path. For example, demo.go imports github.com/another/package, so the directory vendor github.com another package will be searched first. And many people will check the vendor directory into their version control system, which I don't like personally. And what's more, in Java Maven has central repository, so when we need a package, we just say, hey, give me the dependency package with group ID org.undler and artifact ID undler4 and version 4.7. And the repository will answer, oh, here you are, and here are the transitive dependencies stored in pom.xml. Okay? And but in Go, there's no repository. So how can we get the code via the package name? Suppose we need a package named kubernetes.io kubernetes. How can we get that code? Go will try to access this URL. This URL is just the package name plus go-get equals 1. And let's see what's in it. And view package source. Oh, we can see the code repository and VCS2 in meta tag of HTML. So that's Go way. Go package name is associated with its code location, right? If you want to use this package name, you must possess this domain, or you can't find the code. And in this case, the version is something like git commit, git tag, or SVN revision. because the central repository is exactly code repository. And obviously, it's a double-edged sword because while you don't need to maintain a central repository, you lose the flexibility of custom package name, and you lose the transitive dependency information. And there's no official solution for package versioning, so a lot of package management tools appear. Here's an incomplete list of Go package management tools from Go Wiki. Almost each of them maintains a config file or log file to record the transitive dependencies. But unfortunately, almost none of them is compatible with each other. So Gogradle makes some efforts to improve this situation. You can use Gradle init to import dependencies from those tools because Gogradle supports 8 most popular package management tools. Let's see the demo. Still Gogs, I just removed the Go version in build.gradle and run Gradle init. Okay? Wait a second. Okay, done. Cool. So we can see the dependencies are imported into build.gradle. And it's from glide.log. Glide is a popular package management tool in Go community. And that's all. Here are the dependency declarations. Gogradle will also isolate dependency packages into different configurations such as build and test, just like Gradle. And the difference is that it uses tag commit name instead of group ID, artifact ID in Gradle DSLs. And here you can use the short form and the semantic version. And the last line is complex semantic version expression. Here are more complex declarations. You can declare dependency packages with a list or exclude specific dependencies while exclude and transitive. And you can declare a package existing in your local file system only. And how does Gogradle get transitive dependencies? We all know that a good tool should do as much as possible to free user from tedious work. So you should declare the packages you need and let Gogradle handle all other stuff. So, but in Go, there's no pom.xml, and suppose we depend on an external package, and it has dependency packages in its vendor directory, and it may has imports in its source code and log files may have the transitive dependency. Remember that, as we previously mentioned, that the different tools has different log files, right? So Gogradle support 8 mainstream package management tools. So here's Gogradle's strategy. Dependency packages in vendor directory has highest priority than the dependency packages logged in log file. So if none of them exists, Gogradle will parse Go source code to get the dependencies. So in this example, dep1 and dep2 in vendor directory has highest priority. So this package's transitive dependency is dep1 and dep2. And where there is a package management, there is a conflict. suppose our project depends on package A and package B, and they both depend on package C in their vendor directory. How can we determine the eventually used package C, which should be used? Gogradle's solution is first level always win. It means that a user can determine the finally used dependency packages in their build.gradle. And the second, the dependencies has later commit time will win because we have no version, we have no pom.xml, we have only the commit time in our code repository. Yeah, and if there's a situation, you need to manual intervention. So just use Gradle dependencies to see the dependency tree. Let's see a demo. I'm not going to use Gog this time. I'm going to use AWS Go SDK because it has no log files. AWS, OK. And we just run Gradle dependencies. Oh, dependencies. OK. It's pretty much like Java dependencies. We can see the arrow means there's a conflict and a resolution. And there's the star means its descendants are omitted. The interesting part is the very, very long version. So you can see it is a package existing in another package's vendor directory. It's reasonable because we want to all vendor transitive dependency take part in the final build. And you can use Gradle vendor to flatten the dependency tree and install all dependency with specific version into the vendor directory, just as we mentioned before. Vendor is the project level dependency directory of a project. And at last, we need a log file. Just like many other package management tools in many other languages, we need to lock the version to a file, so the build will be reproducible. And we will lock the dependencies into Gogradle.log. And in this case, our package depends on 3 packages, so there will be 3 entries in Gogradle.log. And the interesting is the last part. It has a host and a vendor path because it is a vendor transitive dependency existing in another package's vendor directory. So we just need to run Gradle log to generate that file, so the dependencies will be restored in future. And as we said previously, it's nearly impossible to set a mirror repository in Go because Go's package name is associated with its code location, right? Before you want to use a package name, you must possess the domain. So, but a company may want to set a mirror of GitHub to speed up the internal build or something else. Thanks to Gogradle and Groovy, we can have an elegant solution. This configuration redirects all packages in GitHub to an internal repository. We can see this. It is not a proxy. It just tells Gogradle if you find any packages matching this regular expression, right? And you execute this closure with the package path and get the result URL to get the final repository URL. For example, we have a package named github.com/a/b, and it matches this regular expression. So the closure will be executed with github.com/a/b, and the result URL is https mymirror.com/a/b. It's extremely flexible because you can write any code, use any libraries in the closure, and the root statement is not necessarily a regular expression. It can be any object. We will use Groovy's asCase method to test the package name. And you can specify the VCS via the VCS statement. By default, it's Git, so here the VCS is optional. Currently, Git and Mercurial are supported. After all dependencies are ready, we can do build. With Gogradle, you can have a pretty simple solution to build Go projects. You just need to run Gradle build to invoke Go build to compile your source code into native executables or libraries. Let's see the demo. Still Gogs. Let's run Gradle build. Yeah. It starts resolving dependencies. It's the first time, so it's a bit slow. Yeah, oh, it fails. So let's see the error. When I can see the package missing. Oh, I think I know this error. It's because Gogradle's packaging mechanism is a bit different from Glide, so I just need to remove. We just need to remove these subpackages in build.gradle, and let's run it again. Something are cached, so you can see resolving cached in the mark, and so it's a bit faster. Okay, and looks great. Let's see the Gogs executable. Oh, it's here. I think my time zone is GMT +8, so it's time. Let's try to run it. Oh, it looks great. Just the Gogs, it is a Git service. And by default, Gradle build is equivalent to go build-o output location and your project package path. Note that interesting placeholder. It's for cross-compilation. That means if I write a configuration like this, Gogradle will do the cross-compilation and generate the results for the 3 platforms automatically, just like this. Oh, let's try it. I just need to copy this configuration into build.gradle and paste it. Gradle build. Okay, there's no package resolution because it's up to date. Thanks to Gradle, we can have many intermediate things cached, so we can speed up our build. It's a bit slow because it will invoke go build 3 times to generate different results for different platforms. Oh, it's too slow. Wait a second. Oh, that. let's see the results for different platforms. Oh, it's here. So we can have a really simple cross-compilation. Pretty simple, isn't it? And we just noticed that something are cached. Suppose we have a dependency package with git targ. It is not concrete because git targ can change from time to time. So we need to resolve it to a concrete version, a dependency with commit ID. Okay, it will not change, and then it will be analyzed to get the transitive dependencies, and so we can have some cache strategy because the resolution course can be cached build scope because we just need to resolve once, and in this build we can reuse the result. And then the transitive dependencies are permanent because it will not change, right? A git commit is a history cannot be changed. So we can use the cache strategy to speed up our build. And then the test. Go has its own test tools, but it's a bit inconvenient because it will output all results into console and in plain text. When your project is large, it's a bit hard to find the detailed file test and information. So Gogradle just do something to make it simple to use. We can just use Gradle test to do the test. Let's try it on Gogs. The second, please. Okay, a package test result is here, and it's just like Java test result. I think I can make some tests fail, and let's see what's gonna happen. I'm gonna change the test, and I'm gonna change this not equal to equal. I think this will make sense. And I run Gradle test again. Okay, the package test result. Oh, one failed. So let's see the test report. Okay. It's just like Java test result. We have packages, we have classes, we have standard output. Actually, I just generated data and let Gradle render it for us. And that's all. So, and Gogradle supports test filter, just like Gradle test. And then the code quality. Go has its own code quality tools, such as format or code style. And Gogradle just make it easy to use and out of box. So you just need to run Gradle check to get the test coverage, vet, and format. Let's try it on Gogs. I just need to recover this test file. Okay, and I ran Gradle check. Test. And we can see the vet task fails. Since that is not an accurate tool, I'm going to suppress this warning. I just run that continue when fail equals true. Okay, again. Test. Coverage, format, and vet. Okay, let's see the interesting part. I'm gonna use coverage report for a demo. Okay. See, it's pretty much like Jacoco's Java test coverage. And it seems Gogs doesn't have a good coverage. And let's try to find a test with coverage. Okay. And here the green means it's covered and the red means it's uncovered. Okay. And if you need a custom check task, just declare a task with type go, and run the command in the do last block. Gogradle will inject the appropriate environment variables for you. Remember that Gogradle supports multiple Go versions. So by running the command in this task, Gogradle will inject the appropriate environment variables such as go path and go root automatically. And the last thing to mention is IDE integration. Go is a static typed language, so it would be great to write Go code in IDE. Actually, there are many IDE plugins support Go, and fortunately, Gogradle can be integrated with them perfectly. To generate the IDE configuration, just run the corresponding command. And we will try it on IDEA with Golang plugin. So I'm gonna run Gradle Go IDEA here. Cool, done. And I open IDEA. You should pre-install the Golang plugin for IDEA. And I just open this, Gogs. We have project with Go type, and we have Go 1.8.3 SDK here. It's all automatically. And if I click this symbol, it can jump to the correct location. It's in vendor directory. And let's try to comment one dependency, right? The CLI, your fave CLI, just this. And I click refresh in Gradle window. Because IDEA has Gradle support, so you can just click refresh button in the Gradle window. And wait a second, it turns red, right? Because we just comment its dependencies. And if I remove the comment and click refresh again, wait a second, it turns green, right? And we have tasks in the Gradle window, just like any other Gradle projects. And this is Gradle's main page, and you can find the details, documentation, and the examples there. So that's all. Thank you very much. And do you have any questions? Yeah.
Does the plugin integrate with Gradle's build cache at all?
Not yet, because Gradle build cache is so new.
Do you have plans to work with that?
Yeah, absolutely. Anything else, please?
So you were turning everything into Git commits eventually. For that, is there still kind of a way of having dynamic dependencies, or how do you force it? Do you just do refresh dependencies, or what do you do to try and have it get the next same version tag thing once you've already done it?
Oh, I don't know. I'm not sure I understand the question. So the question is, do I have always refresh the Git commit as the target?
So you want it that way most of the time, but if it's something that can take into a version, you have to go in and find that commit, or do you just, how do you float it? How do you float to the tip of the branch?
Sorry?
How do you float to the tip of the branch?
Typical. Oh, the branch. You mean how can I specify a branch?
Yeah, to the tip. So the latest.
Oh yeah, mercurial tip. Okay. If you so the question is how can I specify a dependency package with latest version or tip?
Right. I think that's what he's asking.
Yeah. So the answer is you don't need to declare any version, or then it will use the latest version for you.
When you do that, does it always go back out and look, or does it use like the caching mechanism they use now for, so for a Java-based one, you can say, I want sort of the latest, but it doesn't go and check every single time. It checks 24 hours or configurable time period.
Yeah.
Have that capability.
So the question is, what is the cache strategy and the refresh strategy of Gogradle? Yeah. The answer is, if you don't do anything, it will it will have a global cache and clone all dependencies into it, and it will try to check out the specific version in it. But if you want to update it, because such as git pull or HD pull, you can add the parameter just -d Gogradle.refresh equal true. Oh, it's just like -- refresh dependencies. It's just that way. Okay. So any other questions? Okay, thank you guys. If you have any questions, I'm right there.